All right, so now given the three sides of a triangle, we're going to know whether the triangle is acute, obtuse, or right. Remember, when we were given the angles, we would just look at the biggest angle of the three, and depending on that angle, if it was less than 90, we'll call it acute. If it was 90, we'll call it right. If it was more than 90, we'll call it obtuse, knowing the angle. But now that we don't know the angle, some of my angles might look like 90 degrees, but they're not quite 90 degrees. So I'm just going to show you guys a method. Okay, so we know Pythagorean theorem. Let me zoom in here. We know our Pythagorean theorem. We have, let's go here. We know that a squared plus b squared is equal to c squared. And that happens when our angle, it's a right triangle. Now, for obtuse and acute, we're going to look at a squared plus b squared is greater than c squared. And then also a squared plus b squared is less than c squared. So notice they all look pretty similar. It's just the sign. It's either equal sign, greater, or less than. Now, the last two are either going to tell me acute or obtuse. The way I would know, to help you guys remember, because I could easily say, well, a squared plus b squared is greater than c squared. That gives you an acute triangle. A squared plus b squared less than c squared. That gives you an obtuse. I can easily just say it. That's how it goes. But how am I going to help you guys? Let's take a look at c squared. C squared happens to be smaller than these two combined. C squared happens to be smaller than those two combined. So this is acute. When it comes to obtuse, look at c squared. C squared happens to be bigger than these two combined. Notice how I'm just looking at the sign. Now, some of you guys might be like, how do I know which side is bigger, which side is smaller? Okay, an inequality side. One side is small. If I had, two numbers, let's say this is a 3. And then notice how this other side is big. The distance here is big. I could have a bigger number, something like this. I know in elementary, when people were comparing numbers, your teachers came and said, imagine this is an alligator. It has teeth. He wants to eat the bigger number. So the open side goes towards the bigger number. So going back to my inequality here, on my second inequality, right, a squared plus b squared is greater than c squared. Notice how the open side is towards a squared plus b squared. So that means that c squared, I'm looking at this one, then notice that c squared is small. So when I say c squared happens to be the smaller side, I'm going to call that acute. Now looking at my third inequality here, my last equality here, c squared is still bigger. So when c squared is bigger, then obtuse. And remember, from the three sides of the triangle, so make sure you know these. From the three sides of the triangle, the one that is bigger, that's the one I'm going to call my c squared, or my c. All right, so here I need to square each of them, because remember in my equations I always had a squared, b squared, and c squared. I always had everything squared. So let me actually square each of them, each of my sides. So looking at question number 13. Let me start with this side. If I was to square the 5 by itself, that gives me 25. If I was to square the radical 3 squared, that gives me 3. So both of them combined, that gives me 75. That's what this side is squared. Looking at this other side, if I was to square the 5 by itself, that gives me 25. If I was to square radical 2, that gives me 2. Now 25 times 2, that means this side is 50. The bottom side, 5 squared, that's 25. Now, I squared each of my sides. Remember I said a squared plus b squared and c squared. From those three sides, the one that is biggest, that is my c squared. All right, so let me add the other two. 25 plus 50. I don't know if I have an equal sign, greater than, less than, so I'm going to leave that empty. And then I'm just going to write 75. That 75 comes from here. Now, 25 plus 50, I know that's 75. All right, that's 75. I get an equal sign. Remember the three things that I gave you guys earlier? Remember when I had a squared plus b squared equals c squared? Because I have an equal sign, I know this triangle is right. So that's what I will write. Right. When you type it, just type that. Because you're typing a word, make sure you, whenever you type it, make sure you type in first letters capitalized. All right, let's take a look at number 14. I have to square each of my numbers. 8 squared, this is 64. Right, 12 squared, right? 12 times 12, this is 144. Radical 82 squared, I get 82. From these three, the one that is biggest is 144, so that's my c squared. So I'm going to go 64 plus 82. I'm going to leave a space because I don't know if I have an equal sign, greater than or less than 144. The one that I leave at the very end is my c squared, the biggest of the three. All right, now combining the first two, 64 plus 82. That happens to be 146. This is 144. Okay, so I don't have an equal sign. So matter of fact, when I see these, I notice that 144, my c squared is smaller than the other two. So I'm just going to call this acute. Notice how my c squared, 144, became smaller than the other two combined. Once again, whenever you type it, because you're typing a word, make sure you capitalize the first letter. So capital A. All right, let's take a look at number 15. I'm going to square all of them. Let me start with the easy numbers. Square root of 7 squared. This is 7. When you squared a square root, you just get the number on the inside. Square root of 10 squared. This is just 10. Now, 3 radical 2. I know 3 squared will give me 9. Square root of 2 squared gives me 2. 9 times 2, that's 18. From the three numbers, the one that's biggest is 18. So that's my c squared. So I'm just going to go 7 plus 10. I'm going to add the two small numbers. I leave a space because I don't know if I have an equal sign, greater than, or less than sign. And then 18. I know 7 plus 10 is 17. 18 is bigger than 17. So notice how I put the open side on the 18. So notice how my c squared, my 18, is still bigger than the other two combined. So I'm going to call this obtuse. All right, easy. Let's take a look at number 16. I'm going to start squaring the numbers that are easy to square. 11 squared is 121. 13 squared is 169. Right, 13 times 13. Now, 3 radical 15. If I was to square the 3, that gives me 9. If I was to square the radical, that gives me 15. Now, 9 times 15, it's 135. From the 3, the one that is biggest is 169, so that's my c squared. I add the two smaller numbers, 135 plus 121, and then 169. I don't know if I have an equal sign in between, a greater than or less than. Okay, so let me add the two smaller numbers, 135 plus 121. That's going to give me 256. And then 169. I'm going to put my inequality sign. The big side, the open side, towards the bigger number. Right? 256 is bigger than 169. Notice how my c-squared, the 169, became smaller than the other two combined. So my c-squared became smaller than the other two combined. I'm going to call this acute. So given the three sides of a triangle, I can easily tell whether we have an acute, obtuse, or right triangle. Don't forget that when you type in the word, because you're typing a word, make sure you capitalize the first letter. All right, let's take a look at number 17 on our notes. 17 through 20, I'm asking, state if each triangle it's a right triangle. So keep in mind, I'm emphasizing on the word here, on the name right triangle. What do we know about right triangles? I know that a squared plus b squared is equal to c squared. Right? That happens in the right triangle. So all I'm asking here is a squared plus b squared equal to c squared? Like a yes or no type of question. All right. Since I'm dealing with the squares, right? A squared, b squared, c squared. What I'm going to do, my three sides of the triangle, I'm going to square each of them. 13 squared, right? 13 times 13, that's 169. The square root of 90 squared, that's 90. Square root 257 squared, 257. When you squared a square root, you just get the number in the inside. From these three, the biggest number is 257, so that's my c squared. So I'm going to add the two smaller numbers, and all I'm asking is 169 plus 90, is it equal to, so I'm going to put a question mark, is that equal to 257? Right, is 169 plus 90, is it equal to 257? All right, well, what's 169 plus 90? 169 plus 90 happens to be 259. Is 259 equal to 257? I'm going to put a question mark. Is 259 equal to 257? So my answer would be no. Make sure whenever you type it, capitalize the first letter. All right, let's take a look at number 18. I'm going to square each of my numbers. 12 squared, it's 144. 10 squared is 100, right? 10 times 10. Now, 2 radical 11, that happens to be 44. I'm going to be like, oh, how did I get that? All right, let's take a look. 2 squared, that's 4. Square root of 11 squared, it's 11. 4 times 11 is 44. Now, from these three, the one that is biggest is 144. So that's my c squared. Remember, all I'm asking is a squared plus b squared, is it equal to c squared? So again, let me put a question mark. All I'm asking is that true? Let me add the two smaller numbers. 44 plus 100, is that equal to 144? Yeah, 44 plus 100 equals 144? Yes. Capitalize the first letter. Looking at number 19. Let me square each of my numbers. Right, 2 squared, that gives me 4. Square root of 2 squared, that gives me 2. So 4 times 2, that's 8. Square root of 6 squared, that gives me 6. Square root of 14 squared, that gives me 14. The biggest number is 14. So all I'm asking is 8 plus 6, because I'm adding the two smaller numbers, is 8 plus 6 equal to 14th? Yes. Take a look at number 20. Going to square each of my numbers. 7 squared is 49. 12 squared, right? 12 times 12 is 144. The square root of 189 squared is 189. From these three numbers, the one that is biggest is 189. Once again, I always squared each of my sides since I'm dealing with a squared, b squared, and c squared. So I already squared those. So that way I can see which one's bigger. It's easy to see. I'm going to add the two smaller numbers. It's 49 plus 144 equal to 189. I'm asking if that's true. Is 49 plus 144 equal to 189? In this case, no. So when I ask you guys, state if the triangle is a right triangle and you have the three sides, you should go for Pythagorean theorem. Is a squared plus b squared equal to c squared. Lastly, let's take a look at these 4 questions. Looking at the instructions, I'm only going to read the instructions on number 21 because it's the same for all 4. Find the missing side of each triangle. Okay, so I'm given 2 sides. I have to find a third side. Leave your answers in simplest radical form. However, let me emphasize something. Each of my triangles, look, they have a 90-degree angle. So they have, remember that box means 90. They have a 90-degree angle, so that means it's a right triangle. What do we know about right triangles? We know that a squared plus b squared is equal to c squared. Given a triangle with a 90-degree angle, right? When we have the 3 sides, it's easy to tell which one is c because it's the biggest of all. Now, when we don't have all 3, the c is the side that is far away from the 90 degrees. So let's see. Question number 21. Here's my 90 degrees. I go through it. This is going to be my C. Question number 22. This is going to be my letter C. Question number 23. This is my C. Question number 24. That's my C. How do I find out the C? Starting from the 90-degree angle, the one side that is farthest away from it. That's my C. Which one's my A and B? It doesn't matter. Do notice, though, that the hypotenuse, the biggest side, the C, could be a number. That's questions number 21, 23, 24. It could be a number, but it could also be the X. In this case, number 22. All right, how do we solve this? I know a squared plus b squared equals c squared. So let me square each of my sides. 10 squared, that's 100. Right? 10 times 10. Radical 37 squared, that's 37. X squared, that's x squared. So the way I'm going to write this, I'm going to go x squared plus 37 is equal to 100. Let me solve for x. Let me subtract 37. So I have that x squared. 100 minus 37 happens to be 63. So that means that x equals the square root of 63. Now, do keep in mind the instruction says leave your answers in simplest radical form. Yesterday, we learned how to simplify a square root. Square root of 63. I'm going to break that into 2 radicals. 2 numbers that multiplied equals 63. One of them must be a perfect square. I'm going to think of 9 times 7 because the square root of 9 is 3. So we have that x equals 3 radical 7. Now, when you type this, do not type in x equals, just type in x 3 radical 7. Remember yesterday we learned how to talk about how to type radicals. You're going to type in 3 radical 7. All right, let's take a look at number 22. Let me square them on my triangle. Let me square each of my sides first. 9 squared, it's 81, right? 9 times 9. X times x, it's x squared. 4 times 4 is 16. So in this case, I'm going to go 81 plus 16 is equal to x squared. 81 plus 16, that's 97. Then I go, all right, 97. Can I think of a number? I start thinking of my perfect square roots because I know x equals the square root of 97. So I start thinking, can I simplify 97? My perfect square roots are 4, 9, 16, 25, 36, 49, on and on. 97. Could I divide this by any of these numbers? And I cannot. So that's as simple as it can go. Now, how am I going to type this? I'm just going to type this rad for radical 97. Nothing came out. All right, let's take a look at number 23. I'm going to square each of my sides. I'm going to start with the easy one, x. X squared is just x squared. Then I'm going to move into 8. 8 squared, right? 8 times 8, 64. And then 16. 16 times 16 is 256. Remember, my 16 is my c, so 256 is my c squared. Remember, when I'm thinking of a squared plus b squared equals c squared, which one's my a and my b? It doesn't matter. So I'm just going to go x squared plus 64 equals 256. Do not square them again. You already did. All right, let's subtract 64 on each side. So I have that x squared. Now 256 minus 64 is 192. So that means that x equals the square root of 192. All right, let's simplify 192. I'm going to break this into two radicals. Remember, my perfect square roots are 4, 9, 16. I'm thinking, can I divide 192 by one of these? I grab my calculator and I go 192 divided by 4. Why did I choose 4? Because that's a perfect square. 192 divided by 4 gave me 48. Oh, so that means 4 times 48. So that gives me 2 radical 48. Right? Because the square root of 48 is, the square root of 4 is 2. Now 48, probably I can do better. 48, I can split that as 4 times 12. Right, this is 2. Remember, I mentioned yesterday that when you have two whole numbers, multiply those. So that's going to give me 4 radical 12. Oh, now radical 12, I can break that as 4 times 3. And then once again, when you have two whole numbers, multiply those. So 8 radical 3. How do I type this? 8 rad 3. All right, lastly, let's take a look at number 24. Let me square each of my sides. 9 times 9 gives me 81. 5 times 5 gives me 25. X times x gives me x to the second power. I know my 9 was my c because it's the side that is farthest away from the 90 degrees. So that's 81 is going to be my c squared. So I'm just going to write this as x squared plus 25 equals 81. Now, let me subtract 25 on each side. 81 minus 25 is 56. So I have x squared equals 56. That means that x must be the square root of 56. All right, simplify your radical. Make sure 56, you start thinking two numbers that multiplied equals 56. Make sure one of them is a perfect square root. I know when we think of 56, we try to go 8 times 7. But neither 8 nor the 7 is a perfect square. So don't go 8 times 7. And now I'm thinking, 4. I grab my calculator, go 56 divided by 4 gives me 14. So that means 4 times 14. And the square root of 4 is 2. So I have 2 square root of 14. Now, 14, I can break that as 2 times 7, but neither of them is a perfect square. So that is as simple as we can go. Now, how am I going to type this? I'm going to type this as 2 rad 14. Make sure you have the parentheses for the rad.